Okay, GERTC buddies. Time to tackle a tough one. Excavation safety.
Yeah.
You know, Deweyville OSH Guidelines 1413.
Right, 1413.
The one that could trip us up on the CE board exam. But honestly, even more important than the exam, this is about real life safety on job sites.
Absolutely. This stuff can literally save lives out there in the field.
No kidding.
Yeah.
I gotta admit, I was totally clueless about this whole excavation safety thing before prepping for this deep dive. But hey, with a master professor here to guide us, I'm feeling a lot more confident.
Well, I'm glad to hear that. And you're right about the importance. It's not just theory, it's about understanding how to keep people safe on actual construction sites.
Okay, so let's start with the basics. What exactly are we talking about when we say excavation? I mean, I get the general idea of digging a hole, but is it really that simple?
Well, it's more than just digging a hole in your backyard for a tomato plant. You know what I mean?
Yeah, I figured there was more to it.
We're talking about creating trenches, foundations, tunnels, anything that involves cutting into the earth, and that's where the danger comes in.
Okay, because a little hole in the ground doesn't sound that dangerous.
Right. Well, the ground itself isn't always stable, so we're talking about cave-ins, falling debris, water accumulation, even toxic fumes. It's serious business.
Gotcha. So not exactly playing in the sandbox.
No, not at all.
So how do we keep things from going sideways? What's the first line of defense?
Shoring and timbering.
Shoring and timbering.
Yeah. Think of it like, building a support system to hold up the walls of the excavation, preventing them from collapsing.
Okay, so we're basically reinforcing the ground to make it safe for the workers down there.
Precisely. And the guidelines are very specific about when this is mandatory. When you're digging deeper than 1 meter.
1 meter, okay.
About 3 feet. You need shoring unless it's solid rock, or the ground is sloped at a safe angle, or no one's actually going down into the excavation.
So if there's any chance of a cave-in and someone getting hurt, shoring is a must.
Got it. Right, you got it.
What about for really deep excavations? Do the rules get even stricter?
Oh yeah, absolutely. For anything deeper than 6.6 meters, that's about 29 feet, you need shoring that's been designed by an engineer.
Wow.
Approved by the authorities and installed by trained professionals. We're not messing around here.
So no cutting corners on the shoring, especially when things get deep.
Nope.
And I'm guessing there are some specific requirements for the shoring itself. What are some of the things we need to know for the exam?
Well, first off, the shoring system has to be strong enough to prevent collapse under any foreseeable conditions.
Okay. So it's got to be sturdy.
It does. And that includes protecting nearby structures, too. We don't want our excavation causing damage to existing buildings or infrastructure.
Right. Makes sense.
And before you even put the shoring in place, you have to make sure the excavation walls are clear of any loose rocks or debris.
Okay. So a clean slate before you start shoring.
Yes. And this is super important. Any excavation deeper than 1 meter has to be kept dry.
Yeah.
Water can really mess with the stability of the soil.
So shoring keeps the walls stable. But what about all the stuff we dig out? Where does all that dirt and rock go?
You mean the excavated material? Or what we call the berm. And yes, there are definitely rules about that.
Okay, good, because it seems like there'd be a lot of it.
Cool.
What does Guideline 1413.02 say about the berm?
Well, it says that the berm needs to be kept at least 1/3 of the excavation depth away from the edge. So let's say you're digging a 3-meter trench. That means the excavated dirt needs to be piled at least 1 meter away from the edge.
So we're not creating a mini landslide by piling it too close. Makes sense.
What if there's not enough space for a big berm, though? Like in a tight urban area?
Good question. And the guidelines address that too. If space is limited, you can work with a smaller berm, but it has to be at least 1 meter wide and made of stable material that won't collapse. And you'll need to put up barriers to prevent any rollback into the excavation.
So no matter what, keep that excavated material a safe distance away. I'm guessing the same goes for tools, materials, machinery. We don't want anything tumbling in there. Absolutely. Guideline 1413.03 covers all that. Tools and materials need to be kept at least 1 meter away from the edge. And for heavy vehicles or machinery, that 1/3 rule applies again.
1/3 of the depth away from the edge.
Exactly. So if you're operating a big excavator near a 3-meter deep trench, keep it at least 1 meter away.
Okay, I'm seeing a theme here. Safety distances are key.
Yes, they are.
So far, we've talked about shoring to hold up the walls, managing that berm of excavated material, and keeping tools and machinery a safe distance. What else do we absolutely need to know about excavation safety?
Well, we can't forget about preventing falls. Someone could accidentally step too close to the edge and, well,
Yeah, not good.
Not good at all. So Guideline 1413.04 focuses on barricades. For any excavation deeper than 2 meters, you need barricades that are at least 1 meter high.
Okay, so barricades are like a safety net around the excavation.
Yeah, you could say that. They prevent anyone or anything from accidentally falling in.
Makes sense. But what about getting in and out of the excavation itself? Can't expect workers to just jump down there.
No, definitely not. That's where guideline 1413.05 comes in. It's all about safe access and escape.
Okay, how do we make that happen?
If your excavation is deeper than 1 meter, you need designated access points like stairs, ramps, or ladders.
All right, so no jumping down into the trench.
Got it. And for ladders, there are specific placement rules. You need to provide them every 16.6 meters, which is about 50 feet.
Got it, so ladders every 50 feet. Anything else with ladders themselves?
Yes. The guidelines say that ladders need to extend at least 0.83 meters above the edge of the excavation. That's about 2.5 feet. That way workers have something secure to grab onto as they climb out.
Okay, another detail I wouldn't have thought of, but it makes sense. So we've covered shoring berms, tools, machinery safe access with barricades and ladders. Is there anything else we absolutely need to know about excavation safety?
One of the most important things, and something that comes up again and again in the guidelines, is inspection and supervision.
Right, because even with all these safety measures in place, things could still go wrong if no one's paying attention.
Exactly. Guideline 1413.06 is all about inspections. For any excavation deeper than 2 meters, it needs to be inspected every single day. And it's not just a quick glance over. It needs to be a thorough check for any signs of trouble.
Daily inspections, got it. And who's in charge of making sure those inspections happen?
The supervisor on site is ultimately responsible. They need to check for things like wall instability, water accumulation, or loose materials, basically anything that could compromise the safety of the excavation.
So the supervisor has a pretty big responsibility here.
They do. It's not just about knowing the rules, it's about actively enforcing them on the site.
And what about the timbering itself? Is there a specific way it needs to be installed and maintained?
Yes. Guideline 1413.07 is all about the supervision of the actual timbering. The supervisor needs to oversee the whole process, making sure every support is installed and secured correctly. And then there's the ongoing maintenance.
We can't just put the timbering in and forget about it, can we?
Definitely not. The supervisor also needs to ensure the timber is well maintained so it stays durable and doesn't deteriorate. Regular checks, repairs, and replacements are key. And here's a detail that might seem small, but it's important for the exam. The guidelines specifically prohibit using timber with toxic sap or water-soluble substances.
Wow, I guess that makes sense. We don't want workers exposed to anything harmful.
No.
So it's not just structural safety, but also thinking about those potential health hazards.
Exactly, right. And speaking of hazards, we can't forget about the risks of harmful gases and dust during excavation work. Guideline 1413.08 addresses that specifically.
Right, because digging into the earth can stir up all sorts of stuff we don't want to breathe in. What precautions do we need to take?
Well, the first line of defense is proper exhaust ventilation. We need to remove those harmful fumes and dust particles from the air. And then, of course, we need to make sure workers have appropriate PPE like masks or respirators.
So it's a combination of engineering controls like ventilation and personal protective equipment.
Right. And what about all that machinery used during excavation? Those diesel engines chugging away. Do the guidelines address those emissions?
I was wondering about that.
They do. For any internal combustion engine, whether it's an excavator, generator, or pump, the guidelines state that the exhaust pipes need to be positioned to direct the fumes away from workers.
Okay, so no one's getting a face full of exhaust fumes. Makes sense. Now, we've talked a lot about procedures and precautions for excavation safety. Are there any specific structural requirements we need to know about, like exact dimensions for the timber?
Yes, there are. Guideline 1413.09 gets into all the details about sizes and spacing for the different shoring members. There are minimum dimensions for safety, and those are definitely things you need to know for the exam.
All right, hit me with those dimensions. What are the key numbers to remember?
Let's break it down. First, you have the sheathing, which is the part that directly supports the excavation wall. The minimum dimension for that is 5 centimeters by 15 centimeters, or if you're working in inches, that's 2 inches by 6 inches.
Okay, 5 by 15 centimeters for the sheathing. What about the other parts?
Then we have the wales, which are the horizontal beams that support the sheathing, and the struts, which are the diagonal or vertical supports. Both of those have a minimum dimension of 10 centimeters by 15 centimeters, which translates to 4 inches by 6 inches.
Okay, so sheathing is 5 by 15 and the wales and struts are 10 by 15. What else do we need to be aware of with these structural requirements?
One very important point. The design of the shoring system isn't just about meeting those minimum dimensions. It has to take into account the specific conditions of the excavation site. the soil, the depth, and any nearby structures. It's not one size fits all.
Right, so a deep excavation in loose soil next to a building is going to need a much more robust system than a shallow trench out in the open.
Yeah.
That makes sense.
Yeah.
You know what else I'm realizing? We've been talking a lot about these specific guidelines, and it's making me think about the importance of having a really sharp, proactive supervisor on site.
Absolutely.
It's not enough to just know these rules. Someone needs to be actively enforcing them and making sure everyone is following them.
Couldn't agree more. A knowledgeable and proactive supervisor can be the difference between a safe project and a potential disaster.
Okay, so we've covered a lot of ground here. Shoring berms, safe access inspections, the role of the supervisor. It's a lot to take in. But before we move on to the next part of our deep dive, let's recap the main points.
Yeah, let's do a quick review. First and foremost, we need to remember that excavation work is inherently dangerous. We're dealing with unstable ground, and there are some serious risks: cave-ins, falling debris water, even those toxic fumes we talked about.
Right, and that's why we have these guidelines, to minimize those risks and keep everyone safe.
Exactly. So we started with shoring and timbering. These are the support systems that prevent those walls from collapsing. And we talked about when shoring is required, the specific requirements for these systems and how crucial it is to install and maintain them properly.
And those safety distances are key. Keeping the excavated material, the tools, the machinery away from the edge. It's all about creating those buffer zones.
Right. And then we discussed preventing falls by using barricades and ensuring safe access and exit with properly placed and secure ladders.
And those daily inspections. The supervisor's job to make sure everyone is following the rules, the site is safe, and any potential hazards are addressed. And we also talked about the importance of protecting workers from harmful gases and dust with proper ventilation and PPE.
Right. And finally, we touched on the structural requirements for those shoring members, emphasizing that the design needs to be tailored to the specific conditions of each excavation site.
Wow, it's amazing how much detail goes into making an excavation site safe. I feel like I'm really starting to understand this, but you mentioned there's even more to learn, right?
There is. Stay tuned, because in the next part of our deep dive, we're going to be exploring the best practices section of the guidelines. This is where things get even more interesting. It's about going beyond those bare minimum regulations and looking at the strategies that really elevate safety on site.
Sounds good. I'm ready for it. All right, so last time we really got into the nitty-gritty of dual OSH guidelines. 1413 for excavation safety. Covered a lot: shoring, timbering, preventing falls, all those hazards. But you mentioned there's even more to learn something about best practices.
Right. Those guidelines have a whole section on summary and best practices, and it's packed with tips that go beyond just the regulations. It's like the wisdom you get from years of experience.
Okay, I'm all ears.
Right.
What kind of wisdom are we talking about?
Well, the first thing they emphasize is that safety should always be the top priority.
Makes sense.
I know it sounds obvious, but it's easy to forget when you're under pressure to meet deadlines and stay on budget.
Right.
But we can never let safety take a back seat.
Right, rushing and cutting corners is a recipe for disaster.
Exactly.
Yeah.
So how do we keep safety front and center throughout the whole project?
Good question.
Communication. That's key. The guidelines stress the importance of clear and constant communication between everyone involved. Project managers, supervisors, workers on the ground, everyone needs to be on the same page.
So regular toolbox talk safety briefings, making sure everyone understands the risks and procedures.
Exactly. And it's not just about talking AT people, it's about creating a culture where everyone feels comfortable speaking up if they see something unsafe.
Right. So anyone can raise a concern without being afraid to speak up?
Exactly. We want everyone to feel empowered to say something if something doesn't seem right.
That makes sense.
Yeah.
It's like shared responsibility for safety. Everyone's looking out for each other.
Exactly. Another big takeaway is the importance of proper training.
Training?
Yeah, everyone working on an excavation project should be trained in the safety procedures.
Well, yeah, we can't expect people to work safely if they don't know how to work safely. What should that training cover?
It should cover everything: hazard identification, risk assessment, the proper use of PPE, what to do in an emergency. It's about giving workers the knowledge and skills to make safe decisions on the job.
So it's not just knowing how to operate the machinery, but understanding the potential dangers and how to avoid them.
Exactly right. And another thing the best practices emphasize is a comprehensive site-specific safety plan.
So not just relying on those general guidelines, each site needs its own tailored safety plan. Why is that?
Because every excavation site is unique. Soil conditions, depth, proximity to structures, the equipment being used, all these factors can influence the safety measures.
So it's like a blueprint for safe excavation for that specific location.
Exactly. What would be included in that kind of plan?
Yeah, what would it cover?
Everything. The shoring and timbering requirements, access and egress, points how to handle the excavated material safety zones around machinery communication protocols, emergency response plan. It's a roadmap for safety.
Sounds like a pretty important document.
It is. And it's not something you just create and forget about. It should be reviewed and updated regularly as the excavation work progresses and conditions change.
Right, things can change quickly on a construction site. So flexibility is important.
It is. So we've got communication training, a site-specific safety plan, anything else.
Yeah, any other pearls of wisdom from those best practices?
Yeah, let's see. Oh, yes. The guidelines highlight the importance of using the right tools and equipment for the job.
Okay, but that seems kind of obvious.
It does. But you'd be surprised how often people try to make do with the wrong tool. And that can be dangerous.
Right. Using a tool for something it's not designed for, that's asking for trouble.
Exactly. And it's not just the big machinery. Even hand tools like shovels and picks need to be inspected regularly and maintained properly.
Wow, never thought about that.
A faulty tool can easily lead to an accident.
So preventative maintenance for all tools and equipment, no matter how big or small.
Right. What else? Let me think. Yes, housekeeping. That's another important best practice.
Housekeeping. You mean like keeping the site clean?
Exactly. A cluttered and disorganized work area is just asking for trouble. Tripping hazards, falling objects, difficulty accessing emergency equipment, it all adds up.
So it's the simple things that can make a big difference.
Exactly. Keep it clean, keep it organized, and keep those walkways clear.
Got it. Any other best practices we should be thinking about?
One more that's worth mentioning is continuous monitoring.
Monitoring?
It's not enough to just have the safety measures in place. We need to constantly check to make sure they're still effective.
So being proactive and constantly assessing the situation.
Exactly. Conditions on an excavation site can change rapidly, and what was safe an hour ago might not be safe now. The guidelines recommend regular monitoring of the excavation walls, the shoring system, weather conditions, anything that could affect the stability of the excavation.
So it's about being vigilant and not becoming complacent.
Right. It's always better to err on the side of caution when it comes to excavation safety.
Absolutely. So these best practices are all about going above and beyond to create a truly safe work environment.
I couldn't have said it better myself.
This has been really helpful. I feel like I'm starting to see the bigger picture. It's not just about memorizing rules for an exam. It's about understanding the why behind those rules and developing good habits that keep us and everyone on site safe.
A comprehensive safety plan.
Yeah.
We need to consider everything, not just the excavation and isolation.
It's all connected.
Right. And save lives.
Well said. I know I've learned a lot from this deep dive. It's definitely changed my perspective on excavation safety.
I'm glad to hear that.
And I feel much more confident about tackling this topic on the exam and in my future career.
That's what it's all about. Remember, your commitment to safety starts now. As future civil engineers, you have the opportunity to make a real impact on the industry.
I'm ready for that.
Good. Keep learning, keep exploring, and stay safe out there.
And that wraps up our deep dive on excavation safety. We hope you found it helpful as you prepare for the CE board exam and your future careers. Until next time, keep learning and keep exploring.